So one of the things that I've been interested on lately in Earth Access, all of this is experimental, so it's not available yet in the main library. But we play with this in a symposium that we had last year in Mexico, and I think it could be very useful for researchers. And that is adding some interactivity to the way we search and visualize data without actually downloading the data. And it's kind of encapsulated in this method called explore that I'll explain in a second. And before I explain that, I think a clarification on the current state of Earth access, right? And what it does, because this is very, or causes some confusion, I guess, when we're like working with satellite data that is not like a global grid. Earth access at the moment doesn't have a subsetting capacity. So when we do a search, and this explains very well what's going on. Say that my area of interest is like the state of Colorado, and we're looking at a collection that has different satellite SWATs on it. What Earth access is doing at the moment is searching for overlaps, filtering the data. So we're not guaranteed that the granules, the files that will come back from the search are going to be just inside the box, the limits of my search. It's more like this. The idea is that eventually we'll have some, interoperability with some services that could provide this, either directly or indirectly. But in the meantime, this is what it does. And I think that's kind of important, because then we'll realize some of the advantages that could have working with cloud optimized data. Okay, so now I just import the libraries. As you probably are familiar with some of these libraries, just like a few lines for X-Array, GeoPandas, and Earth access. So one of the things that a lot of researchers have, like, it's like an area of interest, and normally we start with one of these three files formats. Could be more, but I think these are the most representatives, like either GeoJSON or KML, that's a Google format for Google Earth, and shapefiles. And basically, this feature will support more, I guess. It's a wrapper of this function in GeoPandas with some extra stuff that you'll see in a second. So when we do this with GeoPandas, it uses a library called Fiona to load the file and into memory or data frame. So we have a lot of, it's a pandas data frame with geospatial information. And I just plot the geometry of that, of this GeoJSON, I get this shape, right? So that's, I got it from Global Forest Watch, which is a page that does like, it's a data repository for forest and that kind of stuff. So, well, as I say, you can use a shapefile if you want. Now there is a problem with CMR that this feature will handle, and that is that CMR has a limit for, CMR is the API that NASA exposes for us to search data. So it has a limit in like how complex a polygon can be, and I think the limit is 500 points. So this one, well, I think it has like, over 1,000. And depending on like the resolution of the data that we're searching for, we don't need that, level of accuracy for these overlaps that I show you here. So Earth access will do the simplification for us. And then one of the things that once that we load our geometry or area of interest, and this is the core of the feature, is like we could expose a map to kind of explore the results. And you can see, this is all metadata. We haven't downloaded anything. So if I go to full screen mode, and I'm zooming here my area of interest, you see the satellite ground tracks and different products. So this is coming from a satellite called ISA. This is coming from a mission called JEDI. And these rectangles are from Landsat, basically, HLS. A cool thing about this is that we have in here the summarized information of the search, which is like, if we download this search, it'll be 60 gigabytes of this data set, 37 gigabytes of this other data set, and 1.12. And we can turn it on and off. So I think it's kind of useful to have that. And when we click on one of the ground tracks or the HLS tiles, we get a data preview of that particular tile or a particular ground track. And some products that NASA has have this browse image where we can like inspect what's in the file before we actually download it. And I think that's also very useful for doing some full filtering before we are sure about like what should we be working with. The same thing, like a data preview and some quality flags that we can observe here. And the links for the granule, some size of the granule, that kind of stuff. And once that we do this, I think the next step will be to like have a way to integrate the different data sets. And that's the next thing that I'm working on. So the preview, this is a way of optimizing what we cache in the cloud. I'm not in the cloud, I'm in my laptop. So this is just like, some of this stuff of the cloud don't have to happen in the cloud, but it's faster if we do it in the cloud. This is a big data set that is really not optimized for access, so it takes like 30 seconds to load. But the idea is that once that we have these features kind of like put together in the library, we will be able to replicate something similar to what Google Earth Engine does, but with open source data. And that we can, the other thing is that we can execute the same code regardless of what platform we use it. So I'm using it from my local laptop, but I can put this notebook with environment and Google Earth Engine and Google Cloud Compute, and I shouldn't change. I don't have to change a line of code to work it the same way. Just like some plotting based on. So this is all coming from the cloud. I'm not downloading the whole granule. But I think, yeah, so the bulk of the feature is this widget that we can like explore the data and filter the data. And eventually we can integrate different data sets, because normally it's not just one thing that we are after. It's integrating different satellites from different missions and even different agencies. So that is kind of like questions. I don't know who, I think Bree you have your hand.
Yeah. This looks really cool. What level of so are the same quality filters available for, like, is the whole range of quality filters for each data set available to filter on through here?
Yeah, unfortunately not. Like CMR is not smart enough. We should push some some changes there. Because, for example, one thing that you will be like looking if you're looking at Landsat or HLS is like cloud coverage, for example.
Mm-hmm.
So you put this here, cloud coverage, and basically I'm saying I don't want scenes that have cloud. Now the problem is that CMR is not smart enough to say I'm going to apply this parameter to HLS because that's the only one that has the metadata flag to query cloud cover against. So maybe there is a way, or should be implemented, that you can say apply it only on what's applicable, because what it does is like applies it to HLS or Landsat or the data sets that are applicable, but then it discards anything that doesn't have that metadata in the so I don't get back any of the other ones that cloud coverage doesn't apply, because it's not even, it could be radar or it could be LiDAR. And so, yeah.
Oh, I
That's,
see. So right now, the way that this filter is working, it's applied to all three
yeah,
of the
exactly.
data
Mm-hmm.
types universally,
Yeah.
whether
That's something that CMR
it's
should fix.
relevant or not. Okay.
Yeah. Yeah. Eli.
Yeah. So first, this is really cool. Echo that. Absolutely. I have a question about the code that you're showing right now.
Mm-hmm.
So that format for the temporal is something I haven't seen before. That's like a year range, and then you have like a date range. What's going on there?
Yeah. So, well, one of the things that we haven't exposed is the seasonality, I guess, or I don't know how they call it in CMR, but sometimes you don't really want granules that are like, from winter or from summer, and CMR allows you to do like, okay, for these years I only want this period of time, or cycle. I think it's not really it is something that it's there. We haven't taken advantage in Earth Access, and it has some little bugs like leap years, because it's only transforming the Julian day. So basically saying from the first day of the year to that's what it's under the hood, from the first day of the year to the 100th day of the year. And sometimes that will be one day more or not, depending if it's a leap year or not. So that's something that it might be useful if we know the implications and say, I only want granules for July or March, depending on that's what it is.
Okay. And then the next line, what's going on there with the star geom? I guess I would have expected something like ROI.
Yeah.
equals.
Yeah. So the geometry, once that we load the file, the area of interest, the geometry is just like a parameter that we pass to. It simplified the file, transform it into a GeoJSON compatible polygon dictionary. And the only thing is that this notation basically unpacks that and says, this is equivalent to say polygon equals, and the content of this thing. So it could be the same thing as this. But this kind of looks like, too populated, I guess. So that's what I use, the unpack parameter.
Oh, okay. I didn't know what star meant.
Yeah, it's just unpack the dictionary.
And then kind of the last question. So this comes up, especially when I'm teaching, and kind of I want to come up with a bounding box on the fly. It would be really nice to be able to draw the bounding box.
Actually, yes, you can. You can do something like that. In here, I don't have it wired, but it'll be another 2 lines of code. So basically, it's like this, and then the widget recognizes that you written this, and it will use it for the next search. And you'll see the same thing drawn again. Yeah, but you can also use the polygons.
Amazing. Oh my gosh. This is so great, Luis. I just keeping an eye on time. I know Matt and I had one question, but I wanted to see if anybody else had a question first. So our question was about, you said that you're could you just tell us a little bit about you're working locally, but you're not downloading the data. Are you streaming the data like Alexis was talking about? Okay. And that's, you can, yeah, go ahead.
Yeah, so there are a few issues with that and most of the data that NASA has, as you probably know. And that is that if, look, let's say, let me put this in full screen. So what we're seeing is the visualization of the metadata that we return from the NASA CMR. So this is basically saying, this is what you're going to get if you download or open the granules, the files. This is the orbit. It's a section of the orbit of the satellite. My area of interest is really small. But if I do earthaccess.download, I'm going to get the whole thing, even though I'm not interested in like 99% of the data in that granule, for example. So at the moment, some like the squares here are HLS, so that's COGS. That's great because then I can do stuff with Rio X-ray and other libraries, and I will only be retrieving what I'm interested on for the most part. But these other granules are in HDF format or NetCDF4 format. And that is a little bit more complicated to work with when we're like not in the cloud. So one of the features that it's kind of like hidden here, but I think it's even more important that this visualization is the smart open, as I call it, which is just like a way of saying, I want to cache the granules in a way that if this, for example, if this granule, and normally that's the case for a lot of data sets, inside the file, you have chunks of data. So it's not like a single thing. And the HDF library can like say, like, if this is like 10 chunks, I only want to access the chunk that is like overlapping with my area of interest. But right now, the way the libraries are used in our workflows, it's kind of like counterintuitive for, it will probably do like a full scan to get all the stuff before it hits here. And that's a lot of data transfer. So that's when we say like, oh, if you're not in AWS, it will take forever to access this part of the file. But with Smart Open, you can cache only more or less the part that you're accessing.
Awesome, thank you.
There were some images you were showing earlier, Luis, like some graphs and I think some browse imagery. Are those all like browse images that come with the granules?
Yeah, so all of that is in the metadata. So if you click here, these are the browse images that you get if even with earthaccess has this, like, you know, the pretty print for Jupiter. So if I print the granule, I'll get something similar. It's coming from the metadata links. And I haven't found like a way to represent the links for example, HLS is a multiband and it has like, instead of one file, it has like, you know, the different bands. And I don't know, how can we make it prettier? Each of the bands is a geotiff. So.